In this example, from the large data set, the daily mean wind spread W knots and the daily maximum gust G knots were recorded for the first 15 days in May in Camborne in 2015, shown the data of the wind speed versus the daily maximum gust. The data was plotted on a scatter diagram. For part A, we asked to describe the correlation between the daily mean wind speed and daily maximum gust. So in this scenario, our explanation would be there is a strong positive correlation, and as we can see, the data is compacted, and we can see a positive correlation between the daily mean wind speed and daily maximum gust. And for part B, we asked that to give an interpretation of the value of the gradient of this regression line. So, and also we explained here that why it's a positive correlation as one value increases and the second one increases. Now for part B, our answer will be if the daily mean wind speed increases by 10 knots, the daily maximum gust increases by approximately 18 knots. So there is a relationship between the two. As one increases, the second also increases. For part C, justify the use of a linear regression line in this instance. So in this scenario, the correlation suggests that there is a linear relationship between G and W, which is the wind speed and the maximum daily gust. So linear regression line is a suitable model to use for this scenario. And this will be our answer for this question. In this example, the head circumference y centimeters and the gestation period x weeks for a random sample of 8 newborn babies at a clinic were recorded. We can see the data for the gestation period and the head circumference, and we also have a scatter diagram. So the equation of the regression line of y on x is y equal 8.91 plus 0.624x. The regression equation is used to estimate the head circumference of a baby born at 39 weeks and a baby born at 30 weeks. For part A, we need to comment on the reliability of these estimates. A nurse wants to estimate a gestation period for a baby born with a head circumference of 31.6 centimeters. So in this scenario, the prediction of 39 weeks is within the range of data, as we can see, and that as interpretation as we use within the range of data based on the interpolation, so is more likely to be accurate as long it is within the range of data that we have. For part B, we need to explain why the regression equation given above is not suitable for this estimate. For the 30 weeks, we need to also explain that the prediction of 30 weeks is outside the range of data, so extrapolation, so it is less likely to be accurate. So the 39 weeks was within the range of data, and the 30 weeks is outside the range of data, so that which impacts the accuracy that we will have. For part B, we need to explain the regression equation. So in this scenario, the independent explanatory variable in this model is the gestation period x. So we should use this model to predict the value of x for a given value of y. So it almost a substitution, a value of x to find the value of y. And this will be our answer for this question. In this example, an accountant monitors the number of items produced per month by a company together with the total production costs. The table shows this data. We have number of items and data, and also we have production costs data. So in the first part, we asked to draw a scatter diagram to represent this data. The equation of the regression line of P on N is P equal 21.0 plus 0.98N. And we also need to show for part B, draw the regression line on the scatter diagram. So we plot the data on the scatter diagram, and this is how it would look like, and we also plot the regression line through the data. and this is how it would look like. Now for part C, we need to interpret the meaning of the figures 21.0 and 0.98. The company expects to produce 74,000 items in June and 95,000 items in July. So I will explain in this scenario that if the number of items produced is 0, the production costs will be approximately £21,000. If the number of items produced increases by 1,000, the production costs increase by approximately £980, and this will be our response for part C. For part D, we need to comment on the suitability of this regression line equation to predict the production costs in each of these months. So our explanation in this scenario, the prediction for 74,000 is within the range of data based on interpolation, so is more likely to be reliable. The production for 95,000 is outside, as we can see in the data and the scatter diagram. Is outside of the range of data, so based on the extrapolation, so it is less likely to be reliable. So the 74,000 is reliable as it is within the range of data. The 95,000 is not reliable because it's outside the range of data, and this will be our explanation and our answers for this question. In this example, the relationship between the number of coats of paint applied to a boat and the resulting weather resistance was tested in a laboratory. The data collected is shown in the table, shown on the right hand side. And for part A, we need to draw a scatter diagram to represent this data. The equation of the regression line is y equal to 2.93 plus 1.45x. Helen says that a gradient of 1.45 means that if 10 coats of paint are applied, the production will last 14.5 years. So this is what we need to look into in terms of the scatter diagram. So we will plot the data and we can see how the data is distributed across when we take the production to be in years as the y-axis and the cost of paint as the x-axis. And we also need to take into account for part B that we need to comment on the statements, so that there are two key problems with Helen's statements. So in terms of looking at the information that we have, so first, 10 coats of paint is very far outside our range, as we can see in the data shown, and we cannot assume that this linear relationship continues as we extrapolate. So using the regression line is not necessarily valid. So it is only valid for this data range of data, but outside of that range we cannot guarantee the regression and having the linear relationship. Also, the second reasoning, even if we accept the extrapolation as valid, a gradient of 1.45 means that for every extra coat of paint, the production will increase by 1.45 years. Therefore, if 10 coats of paint are applied, the production will be 14.5 years longer than if no paint were applied. Helen has, however, forgotten to include the constant 2.93 years, which is the weather resistant if no paint were applied. After 10 coats of paint, the protection will last approximately 2.93 plus 14.5, so that means approximately 17.43 years. So in this scenario, Helen only included the gradient factor, however hasn't included the weather impact, which will have a factor of 2.93 in terms of years. So this is our explanation in terms of the two factors and the two reasons for Helen's statement. In this example, the table shows the ages of some chickens and the number of eggs that they laid in a month. So we have a table that shows age of chicken and number of eggs laid in a month. So in the first part of the question, we asked to draw a scatter diagram to show this information, and Robin calculates a regression line of n on A as n equals 16.1 plus 0.063a. So for the first part, we need to plot the data that we have, which will be the number of eggs versus the age in the x-axis. And in this scenario, for part B, we asked to, without further calculation, explain why Robin's regression equation is incorrect. So as shown in the scatter diagram, it's a weak negative correlation. Therefore, the gradient in the regression equation given as 0.063 should be negative, because of a weak negative correlation. And this will be our explanation for this question. In this example, Aisha collected data on the number of bedrooms X and the values Y in thousands of the houses in her village. She calculates the regression equation of Y on X to be Y equal 190 plus 50X. She states that the value of the constant in her regression equation means that a house with no bedrooms in her village would be worth 190,000. Explain why this is not a reasonable statement. So our explanation in this scenario, that this is not a reasonable statement, as there are unlikely to be any houses with no bedrooms. So she is extrapolating outside the range of data, so as she needs to include the bedroom data into it, where the linear relationship is unlikely to continue. So it's unlikely to have houses without bedrooms, and this will be our explanation for this question. In this example, the table shows the daily maximum relative humidity, H in percentage, and the daily mean visibility V dectimeters in Heathrow for the first 2 weeks in September 2015. From the large data set, we have a table of data. The equation of the regression line of V on H is V equal 12,700 minus 106 H. So for the first part, we need to give an interpretation of the value of the gradient of the regression line. So our explanation in this scenario, if the humidity increases by 1%, the decrease in visibility is approximately 1.6 meters. So this will be our explanation in terms of how it will impact, how would the increase in humidity impact the visibility. For part B, we need to use the large data set to explain whether there is likely to be a causal relationship between humidity and visibility. So based on the data that we have, a high humidity of bigger than 95% can give rise to misty and foggy conditions, which in turn will cause lower visibility. Hence, there is likely to be a causal relationship. For part C, give reasons why it would not be reliable to use this regression equation to predict, for part A, for part I, the mean visibility on a day with 100% humidity. So our explanation in the scenario, the prediction for 100% is outside the range of data based on extrapolation, so it is less likely to be accurate. For part I, the humidity on a day with a visibility of 3,000 dectimeters. So how would that be impacted, and if it will be reliable? So our answer will be this particular regression equation should only be used to predict a value of V given H. So almost we can find the value of V based on the value of H. For part D, we need to state two ways in which better use could be made of the large data set to produce a model describing a relationship between humidity and visibility. So our explanation in this scenario, the data provided is only useful for analyzing the first 2 weeks of September. Random values throughout September should be used, and analysis made of the whole month. The sample size could also be increased across multiple months as data between May and October is available. So these are areas that we will need to explore to improve the results and also improve the model that we have. So this will be our response for this question.